Welcome back. This time we're going to talk about intersections and unions of intervals. Interval notation, well, turns out that some sets of real numbers can be represented by intervals and interval notation. And by the way, this really is review from part of Algebra 1 and a lot of Algebra 2. So if I have a number line, and I'm going to let it go from -3 to 3 here, I have it marked off. And if I want to graph x lies between -2 and 3 inclusive, what you probably have learned before is the inequality sign that does not have an equal sign associated with it, like just greater than or equal, then has an open dot. And if it has an equal sign associated with it, it's a closed dot. So we would put an open dot at -2, a closed dot at 3, and connect the two because x is between those two. We're going to learn a new notation where the open dot now is a parenthesis and the closed dot is a bracket. So the way we would graph this using interval notation is to put the parenthesis where the open dot is, the bracket where the closed dot is, and fill that in between. So let's do a little chart here that kind of outlines some of the major things about interval notation. And we're also going to talk about putting it in another kind of notation. So we're going to have interval notation and the associated graph. An open interval would be with parentheses a comma b, which means it starts at a, ends at b, but it does not include a or b. And set builder notation would be the set of x such that x lies between a and b, or you could say the set of x such that a is less than x is less than b. And the graph of that would look like this. A closed interval means that the endpoints are included. So we would have in brackets a comma b. And the way that we would represent that in set builder notation is the set of x such that a is less than or equal to x is less than or equal to b. And the graph would look like this. An infinite interval means at one end it goes on and on forever. In this case, it's going to be the interval goes from a to positive infinity. And the way we would read that in set builder notation is the set of x such that x is greater than a, and the graph would look like that. If we have an infinite interval but it's going in the negative direction, then we would go from negative infinity to b included. Interval notation always goes from the least number to the greatest number, always from left to right. And this would be the set of all x such that x is less than or equal to b, and there is the graph of that. Let's look at interval notation, set builder notation, and graphs for some other problems or for some examples. All right, so the first one is going to be the interval from -1 not included to 4 included. The notation would be the set of all x such that x lies between -1 and 4, or we could say -1 is less than x is less than or equal to 4. Then the graph would be our endpoints are -1 and 4 and everything in between. Because x is between -1 and 4, you can tell that by the set builder notation. Okay, the next one's going to be a closed interval from 2.5 to 4, and now we're going to include both of those endpoints. So in set builder notation, it would be the set of x such that x lies between 2.5 and 4 and includes both those endpoints. And the graph would be like this, with brackets at the ends. Notation for -4 to positive infinity would be the set of all x such that x is greater than -4, and the graph would look like this. Let's talk about unions and intersections. And let's think about a Venn diagram first of all. If I have two circles and the circles are overlapping, the part that overlaps is the intersection. And that means the things that are common to both of those circles or both of those sets. The union is anything that is in one set, the other set, or in the intersection of those sets. So that would be everything. I like to use the example of a local couple of streets and where they meet, North Lake Boulevard and Military Trail here in Palm Beach Gardens. And if I have a young man who is walking down North Lake Boulevard, he shouldn't be walking down the middle, but he is, and a girl who is on Military Trail, and they're looking for their cat that's in the intersection, then the boy is only on North Lake, the girl is only on Military Trail, but the cat, unfortunately, on Military Trail and North Lake, he's in the intersection. But thankfully, no cats were injured in the production of this video, for all of you animal lovers. Okay, let's talk about intersections and unions of intervals. If I have two sets, set A and set B, and let's say set A is 1, 3, 5, 10, and set B is 2, 4, 5, 8, 10, and I want to find their intersection. That would be stating the things that are common to both. So the intersection of A and B would just be 5 and 10, because 5 and 10 occur both in set A and in set B. The union would be any number that is in either A or B or both. So I have 1, 2, 3, 4, 5 occurs in both, but we're only going to write 5 once in our solution set. 8 and 10 that's included in both. So the union of A and B would be 1, 2, 3, 4, 5, 8, 10. Intersection means those things that are common to both sets, and the union means anything that is in one set, the other set, or the union of those two sets. So let's take, now that we're working with intervals and not just discrete numbers, let's use graphs to find each set. So if I want to find the intersection of the open interval 1, 4 and the open interval 2, 8, what I can do is graph them both. I'm going to graph 1, 4 above the line and 2, 8 below the line. So there would be 1, 4, and there is 2, 8. Now what I want to do is find the things that are common to both. So I'm going to draw some little dotted lines where those two intervals cross each other. And that's going to be the open interval of 2, 4. How about let's find the union of 1, 4 and 2, 8. Once again, I'm going to draw my graph. I'm going to do 1, 4 and 2, 8 down below, and I'm going to do my little lines to show what is included in both. And now it's going to be stretching out from the lowest number to the highest number, and that would be from 1 to 8. Now, let's try another one. Let's do the interval of 2, 5, which is closed, the intersection of that, and the closed interval of -1, 3. So, drawing our graph, I'm going to put the 2, 5 above and graph that. And I'm going to put my -1 to 3 and graph that below. Now when I do my lines to find where they cross each other, I have to pay attention because the numbers have to be in the intersection, they have to be in both sets. And you can see that 2, 3 are going to be my endpoints, but we have to now determine if they're included in both or not included in both, so we know whether we're going to use a parenthesis or a bracket. In the first one, 2 is included in the bottom graph, but it's not included in the top graph, so it cannot be included in the intersection. So we're going to have a parenthesis. In the top, it is included in the bottom graph, and it is included in the top graph, so we're going to be using a bracket. If I want to find the union of A and B, remember that's in the things that occur in either or in both. So I have -1, all the way up to 5, and that would be included. All it has to do is be included in one, and the union be included in both. Okay? So now, go do your checkpoints and get ready for the next video. See ya.